Hello, this is Algebra, section 10-4, the Pythagorean Theorem. In this section, I will be talking about what a right triangle is and what it is composed of. Legs, hypotenuse, that kind of thing. Also, about finding values for the different parts of the triangle, knowing the legs, then get the hypotenuse, or knowing any two of the three, getting the third piece. I'm also going to be talking about what are called Pythagorean Triples, where you have three values that represent the three different parts of the triangle, and do these three values produce a right triangle? And lastly, I'm going to be talking about what a converse is to a hypothesis. Be sure to have your journals with you, next to you, so you can take notes, and don't go to sleep. Thank you. Okay, a right triangle. A right triangle looks like this. These are the parts to it. And I'm not as good at drawing a right triangle on a graphics tablet as I am on my notebook, so there you go. Okay, so there are three parts to a right triangle. That part's called the hypotenuse. Over here we have a leg, and down here we have a leg. So we have two legs and a hypotenuse, the three parts to a right triangle. Also, this piece right here, this little square down in the bottom, that tells you that this is actually a right triangle when you look at it on paper. This relationship was discovered by a Greek mathematician named Pythagoras, hence the name Pythagorean Theorem. So the Pythagorean Theorem, in words, says this: the length of the hypotenuse squared is equal to the sum of the squares of the legs. That's what the Pythagorean theorem is saying. Again, if we have a right triangle, it looks like this, and we're going to let this be a leg A, this be a leg B, and C is the hypotenuse. C in these types of diagrams is almost always the hypotenuse. Okay, just letting you know. Then what this says is that C squared is equal to A squared plus B squared. Let's do an example. Okay, let's do example 1 on page 549. And we're supposed to find the length of the hypotenuse of a right triangle if its A and B's legs are, say here's A and B, and there's C. If A equals 8 and B equals 15. I recommend that you always write down the general formula for the Pythagorean theorem, okay? It's a good place to start from. So C squared is equal to A squared plus B squared. All right, so you drop in the A's and the B's that you know. C squared is equal to A is 8 squared plus B is 15 squared, and that's equal to 64 plus 225. And what's that equal? Oh, how about 289? So C squared equals 289. Now back over here, we don't want C squared, we want C. So we have to take the square root of both sides. Okay. So when you take the square root of C squared, that gives you C, right? But when you take the square root of 289, you don't know whether it was a plus or a negative that gave you this value. Whoops, 289. So you have to account for both. Okay, so this is as plus or minus 17. So C is equal to plus or minus 17. Well, we don't have negative distances in real life or in triangle land. So you can't have a negative length hypotenuse. Therefore, C is equal to 17. Okay? Not too difficult. Let's try another example. Let's do example 2. On page 550. Okay. And this is where we are finding the length of a missing side. Okay, so if we have a triangle that looks like this, okay, and this is A, and this is 25, and down here is 10, okay, and it wants to find what the length of A is. So we start out with our Pythagorean theorem. C squared is equal to A squared plus B squared. Now drop in the values that we know. Well, we know C because that's the hypotenuse is always the side opposite of the right angle. Here's the right angle right here. The hypotenuse is opposite of that angle. The legs are the ones that are attached to that angle. C is 25, so we end up with 25 squared is equal to A squared plus B is 10, so that's 10 squared, okay? So 25 squared is 525. I'm sorry, 625 equals A squared plus 100. Okay, now we need to isolate the term with the variable, the A squared. We subtract 100 from both sides, and that gives us 525 is equal to A squared. We need to take the square root. We're just going to work this backwards or rearrange terms. Square root of A squared is equal to the square root of 525. All right, so A is equal to plus or minus the square root of 525, which is equal to around plus or minus 22.91. Okay, so since A cannot be negative, A is approximately equal to 22.91. There's our answer for the length of the leg A. So the next thing that we're going to go into is something called Pythagorean triples. Okay, Pythagorean triples. And basically a Pythagorean triple says these are any three numbers that satisfy the Pythagorean theorem. For example, 3, 4, 5 is a Pythagorean triple. Okay, now of these, how do you know which one is the hypotenuse and which ones are the legs? The hypotenuse is always the largest value, okay, out of these three. 5 would be the length of the hypotenuse. All right, that means then that 5 squared would be equal to 3 squared plus 4 squared. So 25 would be equal to 9 plus 16. So therefore 25 does indeed equal 25. So when you have any set of three numbers and you arrange them in this manner, if you end up with an identity, that is a Pythagorean triple. Therefore, these are the measurements of a right triangle. Let's do an example then. Example 3. And this is going to be on page 550. All right. And they have a triangle here that looks like this, and the endpoints are B, A, C. This is a right angle. This is 20. This is 12. And it wants to know what the area of this triangle, area of A, B, C. Well, we all know what the area formula for a triangle is, right? The area is equal to 1/2 base times height. Okay, well here, the base is equal to what? It's equal to 12. What's h equal to? Well, we don't know. Well, now that we know the Pythagorean theorem, we can find out, okay? So, c squared is a squared plus b squared. Therefore, c squared, which is the longest length, it's 20. It's the side opposite the right angle. So we have 20 squared is equal to 12 squared plus, and we'll say h squared, because right now we're going to let this guy be h, because that's the vertical height. Okay, so we have 400 is equal to 144 plus h squared. H squared is equal to 256. Sorry about that. Therefore, h is equal to 16. Positive 16. I'm leaving off the plus or minus right now because I'm running out of room. So you come back over here then, and we say that the area is 1/2 the base times the height, which is 1/2 the base, which is 12, times the height now, which is 16. That equals 96 units squared. So there we go. That's an example of how we find the height of a triangle without actually knowing it, but we do know the other sides, and we can use Pythagorean theorem to find out what that vertical height was and use it to solve for the area. Now we're going to talk about what a converse is, okay? And so the converse of a hypothesis is where you switch the conclusion and the hypothesis around. So the converse to the Pythagorean theorem states that c squared is equal to a squared plus b squared. So you have these numbers, any two of these, you can find the third. Now the converse of this is basically going to say then that if a and b are the sides and c is the hypotenuse, the longest side, then squaring the legs will give you the length of the hypotenuse. It's just the Pythagorean theorem in reverse, okay? So basically squaring the legs, the sum of those will give you the length of the hypotenuse squared. All right, so this is, in English, this would be the converse. We use this to prove whether groups of three numbers are Pythagorean triples, okay? Remember Pythagorean triples from a couple of minutes ago. So we're going to do an example of this, and we'll do this right here. This will be example 4a, and it says determine whether these three numbers are a triangle with these measurements is a right triangle. So we have 20, 21, and 29. Okay, so looking at this, we know then that the longest side is 29. So C is going to be equal to 29. Now, once we designate C, it does not matter which of the two we put to A and B. It does not matter. A can be equal to 21. B can be equal to 20. So we come back over here and we say A squared plus B squared is equal to C squared. So therefore A is 21 squared plus 20 squared is equal to 29 squared. And if you come out with an identity at the end, then this is a Pythagorean triple. So let's work that out. 21 squared is 441 plus 20 squared, which is 400, equals 29 squared is 841. So 441 plus 400 gives you 841 equals 841. Therefore, this is yes. It is a right triangle. Okay? So, it is important to know what you're trying to prove and then how you're trying to prove it, so that when you get the result, you can look at it and go, yes, this proves it. Okay, we'll do another example. Let's do example 4b. And that says these three numbers, 8, 10, and 12. Find out whether those constitute a Pythagorean triple. All right, let's take the longest side is equal to 12. The longest side is 12. Therefore, we let a is equal to 8, and we'll let b equal 10. So again, c squared is equal to a squared plus b squared. Therefore, c squared, c is 12, 12 squared, a is 8, and b is 10. Well, we have 144 is equal to 64 plus 100. That gives us 144 equaling 164, and that does not. So therefore, this is not a right triangle. Okay? And it's just that simple, really, to determine whether three numbers constitute a Pythagorean triple or not. Okay, thank you very much for watching. If you have any questions, be sure to email me and let me know if there are comments you can make about the video, good or bad. Thank you very much.